There are places out there, billions of places out there, that we know nothing about, and the fact that we know nothing about them excites me. These are not my words, but they are beautifully spoken by Professor Brian Cox, and though the words are his, the feeling is shared quietly by every one of us. Welcome to the Drowsy Astronaut, where we drift into the hidden realms of the universe. Because even the strangest worlds, when seen with patience, can reshape how we feel about the whole. Tonight, we begin a new journey, one that carries us beyond familiar skies, into worlds that stretch the boundaries of possibility, stranger than imagination, yet entirely real in their existence. Now, before we begin, do me a small favor. Let me know where you're tuning in from tonight. It's always a quiet joy to see how many of you join from every corner of the world. And as always, this isn't a lesson to memorize. Think of it instead as a gentle walk with structure, each idea placed carefully beside an image in your mind, moving forward slowly, unhurried, like the universe itself. The worlds we are about to experience will surprise you, some will fascinate you, and some will even amaze you. So I want you to settle into your most comfortable position. Maybe switch on a fan for a soft hum in the background. So, let's begin. The universe holds billions of planets spread across every corner of the cosmos, and most of these worlds are stranger, harsher, and far more extreme than we ever expected. Our Earth feels calm, with steady seasons and breathable air. But countless planets circle other stars, carrying fierce storms, oceans of fire, and unimaginable skies. Every discovery reveals new forms of strangeness, broadening our awareness of possibility. Because true existence is not a line of sameness, but a tapestry woven with chaos and surprise. So when astronomers announce another exoplanet discovered, the word hides a deeper truth, that many of these places are unlike anything we once thought nature would allow. In the early days, exoplanets were only shadows in the light of distant stars. Their presence, guessed from faint dips, repeating like whispers across the brightness of suns. The patterns of those shadows revealed the first unseen orbits, telling us clearly that entire worlds circled far beyond what human eyes could ever reach. Over time, thousands more were confirmed, with names like Kepler 22b and WASP 76b. Each name sounding plain, yet carrying the weight of an extraordinary world. The catalogues of science expanded, growing longer every year, while each entry revealed another strange place where physics worked in wild and unexpected ways. The calm of Earth stands apart when placed in context, because other planets endure storms that tear sideways, rains that melt iron, or temperatures hotter than small stars. In those places, balance is rare, stability fleeting, while our Earth's seasons flow in cycles, gentle enough to nurture forests, oceans, and life. A person might believe Earth is ordinary until seeing the wider sample, for against cosmic others, Earth is revealed as an exception balanced on a narrow line. That contrast sets the foundation for our story, reminding us that knowledge itself can calm by showing how rare stability truly is. Among the nearest examples, Venus is Earth's twin in size, yet its atmosphere crushes with 90 times our pressure and rains sulfuric acid endlessly from its skies. On Io, Jupiter's moon, volcanoes rise taller than any earthly mountain, painting its surface with rivers of sulfur and ash in restless eruptions. Compared to these extremes, Earth feels impossibly gentle, with weather that softens rather than tears, with oceans that nurture instead of burn. But even these violent worlds within our solar system are only the beginning of what strangeness waits beyond our sun. The discovery of exoplanets widened our imagination in irreversible ways, for each confirmation proved that what once seemed impossible was not only possible, but common. We found hot Jupiters circling so close to stars that a year lasted days, where the heat stripped gases away and atmospheres boiled into space. We learned of rocky worlds locked by tides, one half frozen in darkness, while their other hemispheres burned forever beneath unending light. Through each revelation, the message grew clearer, that Earth is rare and strangeness is the true default of planetary nature. The beauty is that even strangeness holds elegance, with alien skies painted by chemicals scattering starlight into shades our eyes have never seen. Some planets may glow red with sodium haze or deep blue with methane, while their clouds scatter light into colors that could never exist here. Elsewhere, frozen gases build crystalline landscapes, reflecting faint sunlight across endless plains, a quiet winter glowing with strange brilliance under alien stars. Through these details, the mind expands gently, resting in the rhythm of variety instead of fear. The truth is that creation delights in diversity, shaping planets into molten spheres, icy fragments, or gas-shrouded giants, each obeying the same laws in different ways. Gravity pulls order from chaos, arranging matter into stable orbits, while starlight paints their atmospheres, deciding heat, color, and possibility for every world. In this way, even the wildest planets follow rules, their motions steady, their orbits repeating across millions of years in silence. So the lesson is balance, though not our kind, a cosmic balance that permits even the most impossible extremes to endure. From Earth, telescopes watch these distant planets through faint signals, and each dimming of starlight whispers another confirmation of a hidden world. The process feels quiet, but its meaning is vast, because behind every observation lies an entire planet turning in the dark. In this accumulation of knowledge, the universe reveals its variety, offering us evidence that imagination itself is too small compared to what exists. And so, the record of impossible worlds continues to grow, guiding our curiosity deeper even as we rest. Even now, every week brings new discoveries, and among them are worlds so strange they defy anything fiction once dared to invent. Some planets glow with oceans of lava, while others glitter with diamond crusts, and still others see glass fall sideways in howling winds. The question is no longer whether such places exist, but how many more forms wait, still hidden beyond our instruments. Through this, the universe reminds us gently that wonder itself is endless, and sleep is only another way of traveling there. You may now let these thoughts rest softly at the edges of awareness, for they are not lessons to remember, but sounds to drift with, steady and calm. The details do not need to stay sharp. They can pass like clouds over a sky, while your breathing steadies, falling in rhythm with the quiet turning of worlds. You are not required to chase every image or fact, only to let the gentle awareness of variety carry you into stillness. So tonight, as the cosmos stretches endlessly beyond, you may close your eyes and know that these impossible worlds continue their orbits while your body rests in peace. The cosmos hides wonders stranger than any dream, and among these some planets carry skies where diamonds do not rest as symbols but fall as rain. In the depths of our solar system, Uranus and Neptune hold conditions beyond our imagination, where carbon atoms are crushed, bound, and reshaped under pressures fierce enough to turn them into crystals. The possibility of diamond rain is not myth or exaggeration. It is the natural result of gravity, density, and chemistry working together at extreme scales. So within these icy giants, storms form unlike any earthly tempest, a strange weather system where diamonds grow, fall, and vanish beneath crushing depths. The journey begins in the upper layers of these planets, where the atmosphere mixes hydrogen, helium, and traces of methane. Under immense pressure, methane molecules break apart, scattering carbon atoms freely into the turbulent air, and from these atoms, new bonds emerge in the form of diamond seeds. Bit by bit, they fall downward, pulled by gravity, growing larger as more atoms attach, until they become actual crystals descending like raindrops of precious stone. The science behind this is grounded in experiment, as high-pressure laboratories on Earth recreate the same conditions and watch carbon transform before human eyes. Imagine the scale: storms larger than continents, filled with diamonds tumbling for thousands of kilometers, yet hidden within the opaque atmospheres of Neptune and Uranus. The journey of each crystal is violent and restless, torn by heat, pushed by turbulence, and forced into depths so heavy no craft could survive. As they descend further, the pressure grows, enough to crush even the strongest earthly materials, until the diamonds themselves melt into a sea of carbon fluid. At that point, no structure remains still. The oceans of carbon swirl endlessly, forming layers within the giants we see only as blue disks in the sky. The idea that jewels fall like raindrops may sound whimsical, yet in these planets it is ordinary, repeated endlessly across centuries without witness. On our world, diamonds form slowly, hidden within rock, forged over millions of years. But in those giants, storms do the work in moments under pressure. Every drop of diamond rain carries the same physical laws we know, only in far stranger settings where scale and energy reshape the rules. So the contrast is stark between the calm value of diamonds here and the endless abundance of them unseen in alien skies. The surface of these planets does not exist in the way Earth has land. Instead, layers of gas compress gradually, thickening into strange interiors. Beneath the atmosphere lies a mantle of exotic fluids, where carbon-rich oceans churn like storms beneath storms, hidden from every view. Deep inside, heat and pressure rise beyond measurement, and the diamonds born above melt again into liquid seas of carbon, restless and unending. This cycle is not one we can see directly, but the evidence comes from physics and chemistry too exact to be denied. Laboratories on Earth have tested methane under crushing force, and the results confirm the theory of diamonds forming as atoms rebind at higher densities. Through powerful lasers and immense anvils, scientists recreate those alien storms, watching tiny crystals emerge where only gas once stood. In every experiment, the same truth repeats. Carbon becomes diamond when squeezed under relentless pressure, just as it would inside those distant worlds. So the certainty grows that beyond our reach, storms of diamonds fall regularly, unseen within the ice giants. The beauty is not only in the diamonds themselves, but in the process, because each storm tells us how matter adapts under forces beyond our daily sense. Through this, nature shows its range, reshaping familiar elements into exotic outcomes, making diamonds not rare, but common in certain parts of the universe. The familiar meaning of diamonds as rare treasures collapses here, for in Neptune's skies, they fall like rain, not stored as ornaments. Such reversals are part of why astronomy carries wonder, showing us how value changes when scale is shifted to cosmic dimensions. Even beyond our solar system, the idea of diamond planets grows, with discoveries like 55 Cancri E, where carbon may dominate its crust and mantle. This super-Earth, twice the size of our own, burns under extreme heat, and its surface may glitter with crystals forged in unimaginable abundance. Such places stretch our imagination to breaking, for entire mountains could be diamond, towering and lifeless, enduring under relentless starlight. The truth is that nature does not favor beauty for us. It only follows rules, and sometimes those rules lead to dazzling extremes. The thought of diamond rain calms and unsettles at once, because it reminds us how different worlds can be, yet how natural their processes remain. A storm of diamonds is wild, but it is also ordinary to physics, the result of pressure and bonds behaving as they must. Every time we hear of such planets, the line between reality and fiction blurs, but the science steadies us, anchoring the strangeness in law. So the calmness of this knowledge lies not in fantasy, but in the quiet assurance that the universe is stranger than dreams, yet perfectly real. The atmosphere of Neptune itself offers little visibility. Clouds of methane scatter blue light, hiding every storm from view. No human eye has seen the rain inside, but the evidence remains, resting in data, pressure models, and chemical tests. A diamond shower may glitter in imagination, yet in reality it would be unseen, swallowed by thick layers, hidden forever in those depths. This absence of direct witness reminds us of humility, that some truths are known only by inference, never by sight. Every discovery carries not just scientific weight, but perspective, for it shows that the universe values variety more than uniformity. In our lives, diamonds are rare, treasured symbols of permanence, but in distant giants, they are simply a phase of matter's endless cycle. The shift in meaning is quiet but profound, reminding us that value belongs to context, not to the element itself. So the universe teaches in silence that abundance in one place may be rarity in another. The story of diamond rain is not only one of physics, but also of scale, because storms larger than Earth itself play out invisibly. Every drop falls through layers beyond endurance, and though no probe can reach them, their motion continues, unbroken, across billions of years. The slowness of our own lifetimes makes us forget such vast cycles, but those diamonds fall endlessly, whether we know or not. Through this knowledge, we see time differently, for patience itself becomes a cosmic force. You may now let the thought of diamond rain drift softly at the edges of your mind, because these storms are not for memory, but for rest. The images do not need to stay exact. They can blur like clouds across thought, while your breathing settles, steady as the orbit of distant worlds. You do not need to hold the science sharply or carry its numbers into tomorrow, for the quiet awareness is enough, calming and weightless. So tonight, as diamonds fall unseen in alien skies, your body rests, steady in its own safe world, while the cosmos continues its quiet story. The universe hides planets where nature reshapes its own materials into brutal skies, and one such place is HD 1897333b, a world where rain falls not as water, but as shards of glass. This planet, discovered orbiting close to a star 63 light-years away, glows a striking cobalt blue. Yet beneath that colour, conditions rage with winds strong enough to carry molten glass sideways at thousands of kilometers per hour. The violence of such a system is difficult to imagine clearly, because our earthly storms, with all their thunder and rain, feel gentle compared to what howls there. Still, this truth stands quietly, that physics does not favour comfort, and the rules of matter continue working, no matter how alien the results may seem. The appearance of HD 1897333b is deceptively beautiful, shining sapphire against the blackness of space, but its beauty hides deadly skies, hostile to any idea of stability. Strong winds, moving at nearly 4,000 miles per hour, tear constantly across its atmosphere, driving molten particles of silicate into streams sharp enough to shred anything caught within. The air there is not like ours, breathable and calm. It is a furnace laced with molten glass, restless, hostile, and eternally turbulent. Even the light from its star intensifies the chaos, heating the atmosphere until particles melt and crystallize again, repeating endlessly across the alien sky. Glass rain begins with silicate vapor high in the atmosphere, where temperatures rise beyond what stone can endure, and molten minerals drift upward in searing heat. The winds sweep them violently, pushing the vapor sideways at impossible speeds, until droplets cool slightly, solidifying into shards that whip through the currents. In those storms, each fragment acts like a blade, small but endless, carving through the air, falling, rising, and scattering until the cycle renews itself. Thus, the process continues unbroken, glass dissolving, reforming, and raining again. An endless weather system beyond any soft human comparison. On Earth, storms bring rain that softens soil, feeds rivers, and fills seas. But there, storms bring glass, cutting instead of nourishing. The contrast between such skies and our own makes Earth feel rarer, for what we see as ordinary rain is a miracle of balance that elsewhere becomes impossible. In HD 1897333b, no calm waits at the end of the storm, for glass does not soothe, it only destroys and repeats itself endlessly. This truth makes the blue planet's beauty deceptive, a shining gem from afar, but a nightmare for any who could imagine drifting within. The heat of this world is another dimension of violence, with temperatures soaring beyond 1,000 degrees, hot enough to liquefy stone. Closer to its star than Mercury is to ours, it orbits in just over 2 days, which means sunlight burns relentlessly, stripping stability from the planet's skies. In such proximity, no surface can survive, and no seas remain steady. Instead, molten minerals rise into air, creating the endless cycle of glass-laden storms. So the pattern continues, one of burning light and rushing wind, where no moment exists free of violence. Scientific instruments tell us more than the eye could see. By measuring spectra, the faint fingerprints of elements scattered in alien light. In these measurements, silicates are revealed in the air, explaining the mystery of its deep cobalt color. Thus, the blue of HD 189733b is not like our oceans or skies, but from molten glass, reflecting light in cruel brilliance against the dark backdrop of space. The lesson is clear: appearances deceive easily, for a planet that glitters like sapphire is also one of the harshest environments yet found. The winds themselves are among the most violent known anywhere, rushing sideways faster than sound, dragging molten shards of silicate across endless horizons. These currents, supersonic in their force, create storms without pause, where the sky itself becomes a weapon, filled with invisible knives tearing through air. In comparison, Earth's hurricanes and cyclones shrink into whispers, for our strongest storms cannot match even a fraction of that alien power. The knowledge humbles us, showing how fragile our planet is, and how balanced it must remain for life to endure. To think of such a place is not to dwell in fear, but to notice how variety fills the cosmos with endless possibility. Each planet, no matter how violent or strange, reflects laws we know well, only applied under greater forces where the outcomes are unfamiliar to us. The rules of physics are consistent, repeating everywhere without error. Yet the results they create are wildly diverse, stretching imagination beyond its edges. So in viewing glass rain as ordinary somewhere else, we see beauty even in conditions that would destroy us. The mystery of this glass world lies also in its colors, for from a distance, the blue light seems calm, glowing like oceans under a star. Yet the truth of that color is violent, born of silicate dust scattering light, not of peaceful waters like those we see on Earth. In that, we glimpse how perception can mislead, and how appearance alone cannot reveal the reality of another world. Thus the lesson carries softly to rest in understanding deeper than surface impressions. The storms of HD 189733b do not end or rest. They continue without break, eternal in their motion. Every moment, molten silicates rise, cool and fall again, raining as glass, driven sideways by winds that never weaken. In the depths of that atmosphere, the process never pauses, so entire cycles repeat endlessly, reshaping the planet's skies into restless violence. From this constancy, we learn that what feels eternal to us is only one expression of the universe's wider rhythm. Even within the violence, there is still a kind of order, for particles rise, fall, and scatter in repeating patterns. These patterns, though hostile to us, reveal balance at their own scale, with every storm feeding the next in endless repetition. In truth, nature does not see violence as disorder. It only sees processes working steadily without regard to our perspective. So even the storms of glass reveal the quiet persistence of law, as chemistry and motion follow their inevitable paths. The thought of glass rain can be unsettling yet calming at once, for it widens our sense of what is possible beyond Earth. Though alien, these storms are natural outcomes, no less lawful than rain upon our world. Every element plays differently when placed under alien skies, showing us that possibility itself stretches far wider than comfort. So the knowledge of HD 189733b becomes a gentle reminder that creation is not limited, but filled with strangeness everywhere. You may now let this thought settle softly into your awareness, for the storm of glass is not meant to be held tightly, only drifted with in calm. The images of blue light and violent skies may blur gently in your mind, while your breathing falls into rhythm, slow and steady, like distant orbits. You do not need to remember each detail or carry sharp science into tomorrow, because quiet awareness itself is enough, soothing and weightless as rest approaches. So tonight, as glass falls sideways on a faraway planet, your body rests, safe within its own calm world, while the cosmos continues its strange and endless story. The planet, known as 55 Cancri E, has been called a true inferno, a place where molten oceans stretch endlessly across its blazing surface. Its orbit is extremely close to its star, so close that a year lasts only 18 hours. And this proximity fills the world with unbearable heat. The heat is not gentle warmth, but temperatures reaching over 2,000 degrees Celsius, more than enough to melt solid rock into glowing rivers. From afar, the world would shine with fiery intensity, a place where lava seas replace any thought of calm landscapes. This planet is classified as a super-Earth, larger than our home but still rocky, though its surface is nothing like the one we know. Instead of oceans of water, waves of molten rock surge and shift, moving slowly yet spreading across every exposed region. The balance of day and night does not exist here, because tidal locking holds one side always facing its star, leaving the other in permanent shadow. Thus one hemisphere endures eternal fire, while the other sinks into endless darkness, a contrast sharper than anything experienced on Earth. The day side is a vision of constant destruction, where seas of lava churn under the relentless glare of their nearby star. Here, volcanoes do not erupt occasionally, but may spout endlessly, releasing fountains of molten rock into the burning air. The atmosphere is thin, uncertain, and possibly filled with vaporized minerals, turning even the faint winds into carriers of toxic heat. On this side, survival is not even a concept, because every moment is drowned in fire and pressure. Across the night side, the opposite extreme unfolds, a realm of freezing cold, cut off from its star's light. Here, temperatures could plummet so low that gases solidify, forming exotic frosts, though some theories suggest heat may spill across, balancing the extremes slightly. Yet still, the division is harsh, a world torn between fire and ice, where neither condition allows for anything resembling life. In this split, the planet becomes a study in extremes, both halves hostile, yet perfectly balanced by their star's grip. To picture lava oceans is to imagine vast expanses glowing like embers, each wave carrying molten stone instead of water. The surface shines in hues of crimson, orange, and radiant yellow, as molten rivers drift, merge, and harden only to melt again. Everywhere, heat dominates, reshaping mountains, flattening landscapes, and refueling endless volcanic flows, as if the entire crust is in constant motion. There is no shoreline of safety, no distant island to escape, only molten currents moving without rest. The science of 55 Cancri E is pieced together from subtle light signatures, patterns in how its stars glow shifts during transit. By measuring those changes, scientists infer heat, chemical traces, and the presence of molten oceans across the surface. This data paints a picture not of habitability, but of a world constantly reshaped, where the surface is never still, never cool, never stable. Each reading reinforces the scale of difference, how alien worlds bend the rules of geology into unfamiliar forms. Some models suggest a world rich in carbon, possibly filled with diamonds deep inside, while the outer layer burns with liquid fire. This composition makes the planet not only bizarre but unique, as if wealth and ruin coexist in constant tension. The crust may be thin, fragile under such heat, unable to hold steady against rising pressures from within. Thus its landscape is caught between collapse and renewal, a cycle written in molten lava. In studying such a planet, we learn what Earth might have been like long ago, when molten oceans covered our young world. Billions of years ago, Earth's crust was unstable, shifting and boiling, not unlike the fiery surface of 55 Cancri E. This reminder tells us creation often begins in fire, that stable continents and oceans come only after eons of cooling. In that reflection, the lava planet becomes less alien, showing the process all rocky worlds must endure. The energy of tidal locking keeps the cycle fixed, trapping one side in unending day. This constant exposure intensifies storms of molten material, perhaps feeding endless volcanic activity. Meanwhile, the night side remains frozen, though volcanic outbursts may spill across, scattering heat unevenly into the cold. This dual nature is striking, a planet in endless contrast, one half burning, the other held in silent dark. The sky over the lava world is imagined as thick and oppressive, glowing with suspended mineral vapors. These vapors, drawn up from molten seas, could scatter light into strange hues, painting the sky with copper, gold, and crimson tones. In such skies, stars may barely pierce the glowing haze, their light dimmed by heat-borne particles drifting endlessly. So even the heavens above reflect the turmoil below, leaving no clear division between land and air. To consider life here is to admit impossibility, for no form we know could withstand such extremes. Every structure, every molecule of biology would collapse in fire before even forming recognizable patterns. This certainty does not diminish the planet's wonder, but reminds us that existence itself relies on rare balances, so the lesson shifts gently to appreciate Earth's narrow comfort, for elsewhere, even rocks flow like water. The violent nature of 55 Cancri E does not end its importance. Rather, it enhances our awe. We realize such worlds are not mistakes, but natural expressions of physics, where energy and gravity write strange landscapes. In this way, we see the cosmos as broader than desire, where not every planet serves as cradle, but each tells a story. Thus, the lava world teaches patience and shows how creation thrives in every form. The thought of such alien seas flowing endlessly across stone is unsettling, yet also calming when seen as distant truth. These oceans, violent though they are, remain stable in their own way, repeating molten cycles over countless eons. In the repetition, there is rhythm, a strange harmony in chaos, as molten currents obey laws deeper than our understanding. So even fire can be gentle when viewed from afar, because the universe holds every scale of expression. The planet called WASP T6b is unlike anything Earth has ever known. A gas giant locked so close to its star that one hemisphere never leaves the day. This world, over 600 light-years away, endures temperatures that reach beyond 2,000 degrees Celsius, hot enough to vaporize iron directly into its skies. The contrast between its day and night sides fuels winds at incredible speeds, carrying iron vapor across the terminator, where shadows cool it into metal rain. Thus the storms here are eternal, never-ending in their violence, rewriting weather into cycles of fire and metal. On Earth, storms begin with moisture rising into the air, condensing and falling again as water. But here, molten iron completes that process in alien fashion. The clouds are not gentle, drifting banks of vapor, but heavy with metallic gases, waiting to cool and fall as liquid fire. Each gust of wind carries vaporized metals, unseen but relentless, pushed by gradients so extreme they defy any earthly comparison. So the cycle never ends, as one side melts and the other freezes, leaving storms as permanent features of its nature. The day side is bathed in endless starlight, radiation pouring down constantly, heating the atmosphere beyond what normal chemistry can endure. On this side, the iron cannot remain solid or liquid. Instead, it lifts into air as a blazing metallic mist. The night side, in contrast, chills enough to reclaim that matter, cooling iron into droplets that fall back as rain. Thus an eternal loop forms. Iron vaporizes, travels, cools and falls, a storm system as alien as it is endless. The winds that drive this system are immense, estimated at thousands of miles per hour, crossing from day to night with unstoppable force. These winds are not the gusts of hurricanes, nor the steady streams of jet currents, but supersonic currents carrying weight no earthly air could hold. In their passage, heat equalizes slightly, but never enough to bring balance, leaving one half forever burning and the other forever cooler. The planet remains in this locked contrast, fire on one side, shadows on the other, storms binding both in their endless journey. The iron rain itself is violent and strange, droplets forming high above, cooling quickly and plunging through the skies. These raindrops, unlike water, fall as molten metal, glowing briefly before hardening, crashing into unseen grounds below or scattering back into vapor. In this cycle, rain is not a nourishing force, but a destructive one, filling the atmosphere with metallic shards carried by brutal winds. So the weather here feels like a forge, repeating endlessly, turning skies into burning furnaces of storm. The clouds may glow faintly with metallic hues, copper, bronze, and steel shades drifting through a heated haze. In contrast to Earth's white or grey formations, these banks shimmer with alien light, revealing the substances hidden in their layers. The star's light itself refracts differently through them, bending off metallic dust into glimmers of strange colour. Thus, the appearance of the planet shifts subtly, as storms and clouds reshape how it shines across the void. Science does not see these storms directly with eyes, but with spectra, the fingerprints of elements captured in distant light. Through analysis, iron vapor reveals itself in the starlight absorbed, proof of storms that rage unseen except through careful measurement. The data confirms theories of heat, wind, and rain beyond water, widening our sense of what climate can mean elsewhere. Thus, each reading expands the imagination, showing how storm is a universal pattern expressed in alien ways. In comparing such storms to our own, humility settles in, for our most violent hurricanes seem like whispers beside them. Earth's winds, fierce though they may be, reach only a fraction of such power, their rain, gentle nourishment rather than burning destruction. This scale of difference helps us see how rare balance is here, where conditions are stable enough for life to endure. So in observing alien violence, we are reminded of fragile peace, a gift found in our familiar skies. The eternal nature of these storms means the planet never changes its course, forever locked in repetition of heat. This constancy is strange, for we often think storms must pass, but here they are, the planet's permanent identity. In such knowledge, strangeness turns to rhythm, and what feels chaotic is really endless stability. Thus, the storms are not disorder but persistence, reminding us how laws of physics write patterns even in fire. The beauty of this world lies in its extremes: cobalt skies, metallic clouds, and rivers of unseen iron. These features, though deadly, paint a landscape as dramatic as any nebula, dazzling with strange light. In our perspective, we may see it as violent, yet within itself it is only consistent, repeating what physics demands. So the wonder remains intact, not lessened by hostility, but deepened by its alien form. The storms also speak of time, billions of years of unchanging repetition across its orbits. In those ages, iron has risen and fallen countless times, leaving no memory except in the present cycle. The persistence itself becomes beautiful, a constant reminder that nature holds patience deeper than human thought. So the planet of iron storms teaches calmness, in its strange way, by showing us eternal motion. The imagination falters when trying to place yourself there, for no human body could endure even a second. And yet the mind can drift across its skies, listening quietly, watching storms that feel more like machines than weather. In those thoughts, strangeness feels less hostile and more wondrous, for the universe has no preference, only endless outcomes. So to know WASP-76b is to widen the idea of storm, far beyond thunder and rain. You may now rest with this thought, carried softly into calm, as the storms of WASP-76b continue their endless cycle, far away, eternal and untouchable. The planet rages beyond your reach, its iron winds howling unseen, while your own world remains quiet, balanced, and safe. You need not picture every detail, nor follow each storm in your mind. Only let their alien rhythm lull you into ease. So tonight the iron rain falls on distant horizons, while here you breathe gently, surrounded by comfort and stillness. The cosmos contains worlds so strange they challenge imagination. Among them lie carbon-rich planets where pressure turns entire layers into crystalline diamonds. These worlds are not myths, but real possibilities shaped by chemistry and physics, where high carbon content, extreme heat, and crushing forces transform ordinary matter into glittering structures. The idea of a diamond planet feels almost like fantasy, yet models suggest such planets could exist in our own galactic neighborhood. From far away, their surfaces might not shine like jewels, but within, the mantle itself could be built of diamond. One candidate often spoken of is 55 Cancri E, already a fiery inferno, but potentially rich in carbon. This composition suggests the possibility of vast diamond content locked beneath its searing crust, a literal gemstone on a planetary scale. The processes that shape it begin with ordinary carbon-rich gas clouds, condensing into rocky bodies under stellar gravity, but skewed heavily toward diamond formation. Thus, the planet may carry layers unseen, diamond-forged under crushing pressure across unimaginable time. To imagine such a place is to picture wealth beyond reason, but value loses meaning when measured on cosmic scales. A diamond the size of a mountain on Earth is unthinkable. Yet in such worlds, it could be only a fragment. The mantle itself may gleam in crystalline structures, though hidden from view, a glittering mass formed under searing conditions. So the concept shifts from wealth to wonder, for diamonds here are not ornaments, but planetary bones. The hardness of diamond makes it fascinating beyond beauty, for entire crusts might be stronger, more rigid, and resistant to erosion. In such a world, geology takes forms unlike anything familiar. Mountain ranges of crystal rising, valleys of fractured lattice spreading. The earthquakes would not sound like those of Earth, but might ripple as resonant vibrations through crystalline layers. Even the volcanoes could differ, erupting molten carbon compounds, reshaping the surface with sparkling fire. Science suggests diamonds may also form deep within ice giants, Neptune and Uranus, within our solar system. There, pressures within their mantles are strong enough to crush methane, breaking carbon bonds and forming falling diamonds. The concept is dramatic, diamond rain cascading for thousands of miles, falling slowly into deeper layers, piling into mountains at unseen depths. So even within our own system, strangeness persists, hidden beneath cold clouds, inaccessible but real. The diamond rain on Uranus and Neptune may be common, not rare, a steady part of their climate. Each droplet begins as methane, split by pressure into carbon and hydrogen, with carbon reorganizing into crystalline structures. Then falling, those pieces drift downwards endlessly until reaching molten mantles where oceans of slush dissolve them once again. Thus, the cycle repeats for eons, unseen but steady, a rhythm of gemstones in alien skies. Some exoplanets may carry this process much further, becoming entire diamond worlds. In carbon-rich star systems, rocky planets may form with chemistry skewed, yielding more carbon than silicates, more diamonds than stone. The outcome would be bizarre geology, glittering expanses under alien stars, crusts unlike anything Earth's surface could replicate. In this way, the diversity of worlds becomes more profound, strangeness expanding our perspective with every new finding. The wealth imagined in these planets is a human lens, but diamonds there are not rare. In cosmic scales, abundance strips away meaning. A diamond world has no jewelers, no buyers, no markets. The value instead lies in physics, in the rules that allow such formations, showing us new sides of planetary creation. So the lesson is gentle. Wealth is relative, but wonder is constant. The heat inside these planets drives crystalline structures further, shaping dense interiors harder than steel, more enduring than rock. In their depths, temperatures might rise higher than any furnace, yet pressure ensures the carbon remains solid. This paradox of heat and stability defines the world's heart. Fire surrounding but frozen crystal at the core. Thus, the planet holds its form, balanced by physics, a diamond globe shining invisibly in darkness. Observations of such planets come from distant starlight, faint dips in brightness as they pass their suns. From spectra, scientists infer their compositions, light revealing hints of carbon dominance. The patterns match theories of diamond-rich worlds, though still unproven without direct exploration. Yet the evidence grows, each signal adding weight, that crystalline planets exist beyond doubt. Imagining walking upon one feels strange, for the surface might not be glittering, but dark and hard. Crystalline formations, fractured and sharp, could stretch across alien planes, reflecting starlight only faintly in cold shards. The beauty would be harsh, less jewel-like than imagined, but magnificent in alien scale. So the vision changes, not sparkling seas of diamond, but barren crusts harder than any mountain. The storms of such planets could be violent in their own way, eruptions of carbon compounds spraying molten crystals. As fountains of diamond dust rise and fall, the skies would shimmer, filled with fragments of molten light. In that vision, storms become glittering events, both violent and beautiful, rewriting weather into strange crystalline patterns. Thus, the climate itself becomes alien, not rain, not snow, but diamond storms. The thought of diamond worlds humbles us, showing how matter rearranges under forces far beyond comfort. What we treasure as rare is commonplace elsewhere, a shift in meaning that widens cosmic perspective. In knowing this, Earth feels precious, not because diamonds are rare here, but because balance allows us to live. So the lesson is not greed but awe, in how the universe reshapes the ordinary into extremes. The giants of ice, Uranus and Neptune, drift quietly at the edge of our solar system, their pale colours masking the mysteries hidden in their deep atmospheres. Both worlds are colder, stranger and less understood than their larger cousins Jupiter and Saturn, yet their interiors may hold storms and rains unlike anything on Earth. Their distance from the Sun leaves them dimly lit, faint orbs seen through telescopes. But within, their processes churn constantly, reshaping gases into new forms. So the giants remain silent teachers, reminding us that beauty can live quietly, unseen by most human eyes. The composition of these planets begins with hydrogen and helium, but far more important are the water, methane, and ammonia, filling their mantles in strange ways. These substances, under immense pressure, transform into states unfamiliar to ordinary experience, producing phases of ice that flow like solids, yet move as if they were fluids. The mantles stretch downward for thousands of kilometers, a crushing ocean of exotic forms, where methane and water alike are reshaped into something alien. Thus, their structures are not frozen still, but restless, layered, and shifting across unimaginable depths. In Uranus, the tilt of its axis sets it apart, lying almost on its side as it orbits the Sun. This orientation means seasons stretch for decades, with poles bathed in light or left in darkness for extraordinary spans of time. The atmosphere reacts slowly, changing patterns across ages, and strange winds carve bands and streaks across the bluish haze. So the planet wears its tilt like a mark, leaving its climate unlike any other giant. Neptune, farther still, carries the most violent winds of any planet, gales reaching over 1,000 miles per hour. These winds howl through its upper atmosphere, shifting clouds of methane into bright streaks, forming great dark spots that appear and vanish over years. The storms on Neptune rival those of Jupiter, though in smaller size, yet they carry greater speed, surpassing anything Earth has ever recorded. Thus, the outermost giant is paradoxical, dim and cold, but alive with raging winds. The methane within both planets gives them their blue hues, scattering sunlight into turquoise and deep azure tones. In Neptune, the deeper shade speaks of more methane and complex scattering effects, while Uranus appears a softer aqua. The skies hide strange chemistry, layers of haze and frozen droplets, concealing what happens in the denser depths, so the colors are only surface hints, veils covering the deeper truths. Theories suggest diamond rain may fall inside these planets, carbon crushed from methane into crystalline forms. As pressures rise with depth, carbon reorganizes, forming glittering crystals that drift downward until they settle into thick layers. This rain is never seen directly, yet experiments confirm such processes can occur, giving strong evidence for oceans of diamonds hidden within. Thus, the giants may hold treasures not of wealth but of science, secrets buried under crushing pressure. The magnetic fields of Uranus and Neptune are strange as well, tilted and offset, unlike the neat dipoles of Earth's field. This misalignment may arise from the structure of their mantles, where conducting slush creates uneven flows, shaping magnetism into chaotic geometry. The result is a field that wanders and wobbles as the planet turns, making radiation belts and auroras equally unpredictable. So the giants challenge models, refusing to fit simple patterns. Exploration of these planets remains limited. Only Voyager 2 has flown past Uranus and Neptune. That journey revealed faint rings, strange moons, and vivid storms. But decades have passed since we gathered new data. The need for another mission grows stronger each year, for these worlds remain the least understood of our solar system's giants. So the mystery persists, wrapped in blue clouds, waiting for patient human eyes to return. Each moon orbiting these giants carries its own strangeness, with Titania, Oberon, and Triton standing as alien worlds in miniature. Triton, the largest moon of Neptune, orbits in retrograde, a captured object likely from the Kuiper belt. The surface of Triton erupts with geysers of nitrogen, faint plumes rising into its thin atmosphere. So the companions of the giants widen the story, proving that strangeness is never limited to a single planet. The cold of these worlds is unrelenting near the edge of sunlight's power, where temperatures drop hundreds of degrees below. In such chill, chemistry works slowly yet steadily, allowing strange molecules to build across long spans of time. The atmospheres are shallow compared to Jupiter, but dense enough for endless movement, winds carrying frozen particles across their heights. So the frozen giants are not still, but ceaselessly moving. The auroras of Uranus and Neptune flicker faintly, born of particles striking magnetic fields. Yet these auroras, unlike Earth's, may glow oddly tilted and displaced, echoing the chaos of their uneven magnetic sources. The beauty of these lights is unseen by human eyes, hidden at the edge of the solar system. So the lights burn quietly, known only through instruments, whispers of distant planetary storms. The history of these worlds may hold answers to formation theories, for their mass and makeup diverge from gas giants. Whereas Jupiter and Saturn gathered hydrogen freely, Uranus and Neptune captured less, building heavier mantles. The difference teaches us about location, timing, and chemistry, each factor writing the story of planetary growth. So the giants are not mere outskirts, but central to planetary understanding. The storms on Neptune remain the most dramatic feature, dark spots appearing and fading within years. Each vortex, large enough to swallow Earth, rotates violently, carrying methane clouds high into swirling bands. The changes remind us that even at the edge, activity thrives, as deep winds rise unpredictably. So the planet remains restless, spinning patterns as wild as Jupiter's, yet uniquely its own. The tilt of Uranus still puzzles scientists, perhaps caused by a giant impact during its youth. Such an event could explain its strange axis and moons, leaving scars buried beneath its clouds. The consequences of that tilt ripple outward, affecting seasons and storms, shaping the climate in alien rhythms. So the planet becomes both scar and survivor, holding the memory of ancient collision. The interior of Neptune remains a mystery, layers of ice, rock, and gas shifting under high pressure. In those depths, exotic forms of water and ammonia may exist, phases unlike any liquid known to us. The conductivity of those fluids may generate its magnetism, shaping strange fields offset from the planet's center. So the core holds answers still hidden, waiting for future human exploration. The moons and rings of Uranus are faint, subtle structures, icy fragments caught in tenuous bands. These rings, dark and narrow, contrast the brilliant halos of Saturn, yet they whisper of formation stories just as rich. The moons carry fractured surfaces, scarred by impacts and tectonics, revealing histories stretching back billions of years. The image of two suns in the sky feels like fiction, yet in reality, binary star systems host many planets. These systems are common across the galaxy, where two stars orbit a shared center, pulling planets into complex paths. The skies of such worlds would hold not one blazing light, but two, shifting in patterns of rising, setting, and overlapping glows. So the concept of double suns is not only cinematic, but a real possibility waiting in the cosmos. In some systems, planets orbit both stars together, circling their combined gravity as one. This arrangement means both suns rise and set together, painting skies with dual shadows across every hill and mountain. The light would be brighter, harsher, and stranger, mixing hues of two different spectra into one blended day. So the planet beneath feels double warmed, its life bound to twin fires. Other planets orbit only one star while the second looms nearby, a glowing presence drifting across the sky. In these cases, one sun dominates the day, while the other adds strange seasons of extra warmth and light. The effect creates complex cycles of heating and cooling as two forces compete for influence across the orbit. Thus, the climate becomes unpredictable, marked by rhythms beyond a single sun. The two suns might differ in color, one blazing white-blue, the other glowing orange. Their rays combine into skies tinted with unusual shades, pale green horizons, violet clouds, or deep golden noons. The scenery shifts as they move relative to each other, casting long shadows or none at all when aligned. So the landscape itself would glow strangely, lit by dual spectra in unfamiliar harmony. The pull of two stars reshapes orbits dramatically, dragging planets into unusual paths. In some cases, stability endures for billions of years, while in others, chaotic motion flings worlds into darkness. The calculations of these systems are intricate yet beautiful, revealing delicate balances hidden within complexity. So the existence of planets in binaries reminds us that order can emerge from cosmic tension. The sunsets of such planets would be extraordinary, with one star dipping low while the other lingers above. In that moment, skies would blaze in colors unknown on Earth, overlapping hues as one sun fades and another persists. The cycle would never feel ordinary, for no day would end the same, each evening painted uniquely by shifting lights. So the experience of time itself would alter, with nights delayed or shortened by two suns' motions. The moons of these planets, if present, would add complexity, reflecting light from two sources. Each phase would differ, caught between competing beams, glowing with double illumination as it drifts across the night. The stars behind would fade differently too, hidden by the brightness of dual suns. So the sky above would never resemble Earth's, a canvas marked by overlapping patterns. Seasons on such planets might be extreme, as both stars pull climates into unusual shifts. In binary orbits, one sun may heat strongly while the other recedes, causing violent swings in planetary temperature. The result could be decades-long summers or winters, dictated by stellar alignments. So the inhabitants of such worlds, if any existed, would live under long, irregular cycles. The psychology of living beneath two suns is worth imagining, for constant brightness reshapes our sense of day. With light flooding from different directions, shadows multiply and distort, creating unfamiliar environments. So the concept of time itself feels altered, when no single sunrise or sunset governs the sky. In literature, twin suns have symbolized hope, mystery, and longing because the image is powerful even without science. Yet astronomy tells us these systems are ordinary, not rare, common outcomes of stellar formation. The fact that planets can exist within them strengthens the wonder, because these stories carry truth, not just fantasy. So the vision of a double sky rests not in myth, but in astrophysical reality. The temperatures of these worlds may swing between extremes, depending on stellar type and distance in orbital motion. In some cases, both suns warm gently. In others, fierce radiation scorches atmospheres. The climates may become unstable, too volatile for life, though possibility always clings to diverse conditions. So the hope of habitable binaries persists, fragile but not impossible, as nature surprises with its diversity. The history of exoplanet discoveries includes several in binaries, including Kepler 16b, a gas giant in a circumbinary orbit. This world proves that such planets exist, not just in models, offering direct evidence. The transit of Kepler 16b across its suns is striking, a small shadow crossing two stars at once. So the proof is here: twin suns can host planets, and those planets may endure for eons. The possibility of life on these worlds is uncertain, but not beyond reason, depending on stable zones. If orbits hold long enough, climates may steady into ranges where water remains liquid. The odds are slim but real, allowing even strange binary worlds to host biology. So the dream of twin sun life endures, gentle and persistent within the cosmos. The perspective of distance makes these worlds feel cinematic, but they are as real as any other system. In truth, Earth is unusual for having only one sun. Many stars are born in pairs or groups. The familiar thus becomes rare, and the strange becomes common, reshaping our view of normality. So the knowledge of binaries softens our arrogance, reminding us that Earth's conditions are only one among many. The night sky of such planets would still exist, but dimmer, because dual suns keep darkness short. Even at midnight, one star might remain lingering above horizons, painting skies with unusual glows. The stars behind would fade into faintness, lost against dual light. So the darkness there is not absolute, but a softened, glowing twilight. The galaxy hides worlds without suns, drifting endlessly through interstellar darkness. These are the rogue planets, cut free from their original systems and wandering cold across eternity. Such worlds do not orbit a star, but instead roam silently through the void, their paths determined only by the gravity of past encounters and cosmic accidents. The numbers may be immense, perhaps billions of these solitary worlds across the Milky Way, making them more common than planets orbiting stars, yet far harder to detect. So the concept of rogue planets expands our imagination, revealing how planetary existence can continue even in absolute darkness. Without a parent star, these planets live in shadow, their skies empty of dawn or sunset. The cold consumes them, temperatures falling close to absolute zero, unless internal heat from radioactive decay or formation lingers deep within. Some may carry thick atmospheres that trap what little warmth remains, creating strange environments far removed from anything we know. Thus, the possibility exists, however faint, that even such worlds may shelter hidden oceans. The discovery of rogue planets often comes through microlensing, where their gravity bends light from distant stars passing behind them. In this way, astronomers detect the unseen by measuring distortions, gravity itself becoming the only signature. The signals are brief and subtle, vanishing as alignments shift, but they provide undeniable evidence of wandering worlds adrift. So the science of rogue planets is indirect but profound, reminding us how light is not always necessary to reveal truth. Some theories suggest many stars eject planets during formation, their gravity slingshotting smaller worlds into deep space. These ejections may explain the sheer number of rogue planets scattered everywhere, lost siblings of stars thrown into solitude. The violence of early solar systems ensures not every orbit can last, instability casting planets outward like discarded fragments. So the dark is full of such remnants, survivors of chaotic beginnings. A rogue planet may retain moons despite its exile, small companions orbiting even without a central sun. In these cases, moons reflect no sunlight, glowing only faintly from internal heat. The systems wander like miniature solar systems stripped of stars, self-contained, drifting alone yet carrying hidden relationships. Thus, the story of rogue planets is not always solitary, for even in darkness, gravity builds quiet connections. Some worlds might carry thick blankets of hydrogen gas, enough to insulate their frozen cores. These atmospheres could trap geothermal warmth from radioactive decay, leaving liquid oceans hidden beneath high pressure. The possibility of life clings faintly even here, not on the surface, but perhaps in deep layers shielded from the void. So the lesson remains that life seeks every crack, filling even the coldest planetary secrets. The absence of a sun does not erase all light. Some rogue planets may glow faintly in infrared radiation. In this way, their heat betrays them to instruments, telescopes designed to catch faint whispers of warmth. The glow is dim, invisible to human eyes, but clear to sensitive detectors watching distant patches. So the darkness is never complete, even for worlds adrift. Some fire still burns faintly within. The movement of such planets is slow and silent. No star to race around, no familiar orbital period. Instead, they drift through the galaxy, crossing thousands of light years across billions of years. Their journeys are rarely interrupted, falling into new systems after unimaginable time. So the destiny of rogue planets is often endless solitude, but sometime rebirth under alien suns. The loneliness of these worlds is hard to describe, for no sky ever brightens with morning light. In their darkness, the landscape may freeze into stillness, continents and oceans locked in icy prisons. The silence would be overwhelming, deeper than anything on Earth, where even wind and water cannot break the stillness. So the essence of rogue planets is isolation, carried across the galaxy without companions. Some giant rogue planets may resemble Jupiter, vast spheres of gas adrift in the interstellar void. These giants may still carry swirling storms and deep atmospheres, internal heat keeping them active despite the absence of sunlight. Their clouds could churn in darkness, unseen but restless, massive systems fueled only by gravity's slow decay. So the giants of the dark remain dynamic. Even in silence, they retain moving hearts. Others may be smaller rocky planets, more like Earth, but frozen through without stellar warmth. In those cases, Ice blankets their surfaces, stretching unbroken across frozen seas. Their insides may remain warm, geothermal fires resisting the void, heating small pockets where liquid might survive. So the contrast between surface and interior becomes profound, with life possible only beneath frozen shells. The count of rogue planets could be higher than stars, outnumbering suns across the Milky Way. This suggestion changes our sense of rarity, making lonely worlds the dominant outcome of planetary formation. The cosmos thus becomes even stranger, filled less with glowing systems and more with wandering darkness. So the night is deeper than we imagined, with countless hidden planets drifting unseen. The origin of such planets can differ greatly, some born in systems and thrown out, others forming directly in interstellar clouds. These free-floating formations blur the definition of planet, standing between stars and smaller bodies. The boundaries of classification stretch thin here, showing how categories bend under cosmic diversity. So the labels we invent often fail, for the universe resists easy definition. The idea of travel across such a world chills the mind, endless night stretching without sunrise. In this perpetual darkness, navigation would be impossible without instruments, for no stars guide the way from such a horizon. The surface would be desolate, an eternal frozen plain, broken only by occasional geysers or volcanic plumes. So the experience of standing there would be overwhelming, a silence beyond human endurance. The moons of rogue planets, if they exist, would orbit quietly, glowing only in reflected starlight from galaxies far away. These companions might provide faint relief from the void, circling endlessly, loyal to their parent world. Their motions would offer a kind of rhythm, marking time in the absence of days. So the bond between planet and moon feels more sacred, tied by gravity alone in isolation. The search for rogue planets has only just begun. Telescopes in the coming decades may reveal thousands of examples. Through infrared surveys and microlensing events, evidence will grow until wandering planets are known not as rare oddities, but as norms. The recognition will change our view of the galaxy, where starlight becomes less central than gravity. So the map of our cosmos will fill with dark worlds, unseen companions of every path. The twilight worlds exist between extremes where light never fully fades and darkness never fully arrives, balanced eternally in half-lit skies that never rest. These planets are tidally locked, one side scorched by constant starlight, while the other remains in endless shadow, leaving a narrow twilight strip between. The strip is where temperatures soften, not boiling and not freezing, creating strange zones that could remain habitable in rare conditions. So the beauty of twilight worlds lies in balance, caught forever between fire and ice. In such systems, the star burns closely, holding the planet's rotation in place, forcing one hemisphere to eternal day and the other to endless night. The contrast is staggering. One side blasted by heat while the other sinks into frozen silence. Both extremes lethal to familiar life. But along the boundary, twilight holds steady, a permanent evening where golden light bends softly across alien horizons. So the possibility of survival concentrates here, within the strip of permanent dusk. The skies above such a boundary glow differently than ours, blending deep colours, with faint stars barely visible beyond the eternal haze. On Earth, twilight lasts only moments, yet on these planets, it continues without end. Skies painted endlessly in subtle tones. The atmosphere may swirl in unique ways, circulating heat from day to night, shaping winds unlike any weather known here. Thus, the climate becomes a complex balance, with storms perhaps endless but softened in twilight zones. To live on such a world would be to never see sunrise or sunset, only the steady glow of in-between light. The shadows would stretch forever, never shortening or lengthening, casting strange patterns across landscapes held in eternal dusk. Plants, if they could grow there, would adapt to steady illumination, evolving under constant light, neither bright nor absent. So the rhythm of life would be unfamiliar, but still possible in twilight bands. The star itself may always hover low in the sky, casting slanted beams across clouds and distant mountains. This image would become the only horizon known, neither rising nor falling, but locked forever in the same place. The landscapes beneath would reflect this light uniquely, glowing in permanent gold or violet sheen. So the beauty of such a world would be haunting, colours unchanging, shadows stretching endlessly across valleys. The extremes on either side define the balance, one hemisphere frozen into lifeless ice, the other burning under constant flame. Between them, twilight acts as mediator, softening chaos into fragile calm, creating a narrow ring where chance may favour survival. This ring could circle the planet, habitable only in strips of land or water, where heat and cold equalize. So the potential of twilight worlds is profound, balance carried across narrow planetary belts. Science studies such planets carefully, labeling them as tidally locked exoplanets, many found within habitable zones of red dwarf stars. These stars are cooler than our Sun, but close orbits trap planets tightly, leaving them in locked positions. The habitable strip becomes the place of interest, where liquid water might exist, even without ordinary day-night cycles. Thus, the focus on twilight planets grows stronger, offering strange but real chances for alien life. The atmosphere of such worlds determines survival. Thick layers may spread heat evenly, while thin ones fail to protect. In cases of thin air, one side bakes relentlessly while the other freezes, leaving only twilight with fragile stability. The thicker atmospheres, however, may smooth the contrast, creating milder climates where life may persist. The winds here could be fierce, rushing constantly between hot and cold, carrying clouds from blazing day to frozen night. In that movement, strange cycles may appear, storms circulating endlessly between light and darkness. The cycles might mimic Earth's jet streams, but larger, faster, more violent, spreading gases and heat between hemispheres. So the weather of twilight worlds is both predictable and alien. Permanent winds carving endless patterns. The oceans of twilight worlds, if they exist, would stretch strangely, partly frozen on one side, boiling near the other edge. In the middle, waters could remain liquid, flowing endlessly under eternal skies. a perfect balance between two extremes. Currents might move differently, driven by heat from one hemisphere, circling into the frozen half with strange flows. Thus, the seas could act as regulators, smoothing chaos into twilight calm. The surface may glow under steady half-light, golden hues giving way to violet or deep crimson skies. On land, mountains and valleys would remain frozen in endless shadow or melted under blazing light. The strip, however, remains liminal, neither one nor the other, where steady illumination shapes unique geology. So the planet as a whole feels divided, yet unified by the narrow belt of twilight. In culture, twilight worlds would shape thought differently. Life there would never know true night, nor would it know sunrise, only a steady horizon locked in eternal evening, time measured by winds or patterns instead. The societies born there would think of light differently, with no concept of daily change. So the psychology of twilight could be profound, life rooted in steady half-light rather than cycles of day. The discovery of exoplanets near red dwarfs makes twilight worlds likely, common in habitable zones. Many findings from Kepler and TESS reveal candidates fitting these models, planets where eternal twilight bands might exist. The search continues with growing precision, measuring atmospheres and temperatures, seeking faint clues to hidden oceans or air. So the evidence grows stronger each year, that twilight planets are not rare but frequent. The twilight is also poetic, a symbol of balance, neither blazing with heat nor lost in frozen silence. It becomes a metaphor, reminding us that extremes rarely hold life, but margins and edges do. The margins of the cosmos are as fertile as centers, proving that even narrow twilight strips hold promise. So the lesson is soft but clear. Balance breeds possibility, even in alien worlds. You may now rest with this thought, holding softly the image of half-lit skies, where twilight remains eternal. The planets continue far away, locked between extremes, their golden dusk steady, while your breath slows into calm rhythm. You do not need to follow every detail, nor carry each calculation, for gentle awareness itself is enough. So tonight, as twilight settles over imagined horizons, your body rests, safe in Earth's cycle of day and night. The extremes of planetary climates often split worlds in two, leaving some as blazing furnaces and others as frozen deserts. These contrasts reach their peak in planets where fire and ice coexist, locked together in cycles of violent heat and absolute cold. The balance is often unstable, with atmospheres unable to even out such chaos, leaving each side ruled by a different destiny. So the lesson of fire and ice worlds is contrast, that creation does not settle into one pattern alone. Some exoplanets orbit so close to their stars that surfaces melt entirely, while their far sides freeze into sheets of ice. This configuration creates planets divided directly down the middle. One hemisphere a burning inferno, the other a frozen wasteland. The twilight strip between those halves becomes the only narrow chance of habitability, a permanent band of balance between opposites. Thus, the concept of survival shifts to margins where extremes cancel, leaving a fragile place of calm. The physics behind this lies in tidal locking, where one face of the planet remains in constant day. That day burns relentlessly, heating surfaces beyond recognition, while the opposite side remains in frozen darkness. The result is a world torn apart by imbalance, both faces inhospitable except for the narrow ring in between. So the structure of these worlds teaches patience, showing how survival clings only to thin zones. In certain cases, the day side may glow with molten rivers, while the night side hardens into glacial walls. The contrast is stark, one half blazing red, the other shimmering blue-white. Landscapes built by two different forces. Seas might boil on one side while freezing on the other, producing violent currents in oceans that stretch across both extremes. So the planet embodies paradox, a single sphere carrying opposite fates. The weather in such environments is equally strange, with winds racing from fire to ice at impossible speeds. These winds attempt to balance heat, but only spread chaos, carrying storms across permanent twilight belts. The clouds may glow with vapor on one side and ice crystals on the other, merging fire and snow in alien skies. Thus, the climate is never stable, but an eternal cycle of violent exchange. The chemistry of these worlds is also shaped by extremes, minerals vaporizing on one side and freezing solid on the other. In such conditions, even iron may rain down molten on the day side, while forming brittle crystals in night-side frost. The geology shifts constantly, surfaces boiling away before hardening again. Strange patterns etched across landscapes forever torn apart. So the appearance of these planets would be surreal. Alien artworks painted in contrasts of fire and ice. Kepler discoveries revealed several candidates for such planets, tidally locked worlds orbiting small stars. Among them, Kepler 10b stands as an extreme where dayside heat could vaporize rock. The observations suggest a surface that cannot stabilize, one half a furnace, the other a frozen wasteland. Thus the evidence for fire and ice planets grows steadily, pointing to diversity beyond our familiar Earth. On Earth, fire and ice coexist in volcanoes, glaciers, and polar seas, but never across an entire world. The comparison reveals just how balanced our climate is, how fragile life becomes when heat and cold are separated too widely. In imagining exoplanets split in halves, we see Earth's rarity, how equilibrium is precious and rare in cosmic terms, so the value of balance grows clear, reminding us of our delicate fortune. The twilight belts of such planets remain areas of fascination, narrow zones where temperature may allow liquid water. These belts may stretch like thin ribbons around the planet, endless sunset lines that never shift or fade. Their skies would glow permanently in oranges and violets, the light always slanting low against the horizon, so the experience there would be haunting, neither fully day nor fully night. The oceans of fire and ice worlds may circulate heat strangely, boiling on one side and freezing on the other. Currents could move endlessly between extremes, spreading warmth into twilight, creating strange balances of chemistry and motion. The possibility of alien biology emerges here, adapted to strange rhythms, forming within twilight seas under constant change, so the chance of life persists even in extremes, shaped by fire, softened by ice. The symbolism of these worlds is striking, half blazing with fury, half frozen in silence, a cosmic yin and yang. In their form, the universe shows its own contradictions, opposites locked into one sphere. The beauty is in the persistence of both extremes, not victory of one, but shared existence. So the lesson is broader than science, reminding us that opposites can remain bound in quiet tension. Some theories suggest atmospheres may circulate enough heat to soften extremes, smoothing fire into warmth and ice into softer chill. If true, these planets may be more habitable than expected, their belts wider, climates gentler, survival more possible. The variations depend on thickness of air, rotation, and distance from the star, each factor reshaping outcomes. So the possibility of fire and ice planets broadens, reminding us of endless planetary variety. The future may reveal more of these strange worlds, as telescopes sharpen their view and expand their reach. Through spectra, we may glimpse chemical signatures in twilight belts, the faint fingerprints of alien conditions. The search continues with patient surveys, gathering hints of atmospheres, oceans, and frozen lands. Thus, the mystery of fire and ice remains open, waiting for human curiosity. The landscapes of these worlds would be surreal in vision: lava plains against frozen seas, mountains of ice may border molten canyons, geological wonders created by split forces. Their skies could flash with lightning storms carrying strange chemistry, where molten vapors mix with freezing clouds. So the view from afar would be haunting, beauty carved by extremes, enduring in alien balance. The journey through fire, ice, twilight, storms, and endless galaxies has brought us deeper into cosmic truths, showing contrasts, balances, and fragile moments where possibility itself blooms. In every chapter of this unfolding story, creation revealed itself slowly, carrying both chaos and order through scales we can barely grasp. The narrative stretched from the first seconds of expansion to twilight belts of alien planets, reminding us that the cosmos is endless in forms. So the path we walked was not only factual, but a soft rhythm, helping the body drift toward rest. The silence that followed the Big Bang grew into light and stars, while time carried structure into galaxies and planetary systems. From the earliest fractions of a second, matter arranged itself quietly, and the faint hum of physics became steady laws. The echoes of that birth remain across space, still glowing as microwave background, a whisper of beginnings no eye can ignore. So the memory of the universe lies everywhere, hidden within particles, carried through ages of expanding space. The galaxies emerged from darkness like luminous islands, each one a cradle of suns and swirling dust. In clusters, they formed vast webs of connection, filaments spanning billions of light years, weaving structure into cosmic fabric. The stars burned with fusion, creating heavy elements slowly, scattering them in death, enriching the universe with seeds of life. So the continuity of creation shows itself clearly, that endings always lead toward new beginnings. The planets born from such debris circled stars endlessly, some scorched, some frozen, others balanced into rare habitats. In their variety, we saw storms of methane, rains of diamonds, and winds stretching thousands of miles per hour. The contrasts grew stranger the deeper we looked. Twilight belts, lava oceans, and glacial hemispheres of divided worlds. So the lesson again returned to variety, that no single path defines the cosmic tale. The twilight planets showed us balance, strips of eternal dusk where life may cling, even while fire and ice surround. In fire and ice worlds, survival rested within narrow margins, thin bands where chaos softened into fragile stability. The extremes always pressed, yet left narrow havens, where water could remain liquid and atmospheres could shelter fragile forms. So the paradox was clear, that survival exists most often at edges where opposites meet in uneasy peace. The storms of alien skies carried endless power, winds shaping planets with energies beyond familiar scale. In gas giants, those tempests stretched wider than Earth itself, rolling endlessly, painted in stripes of coloured clouds. The violence of such atmospheres stood alongside beauty, lightning flashing through haze, auroras bending over swirling bands. So the image of storms became permanent, not threats alone, but movements within living systems. The frozen worlds reminded us of silence, vast expanses without sound, locked in deep cold. On such spheres, ice spread endlessly, reflecting starlight faintly, with surfaces brittle beneath fragile skies. Their loneliness was sharp, yet carried dignity, proof that even frozen matter holds meaning across cosmic time. So the contrast between heat and frost deepened, guiding our thoughts into softer awareness of fragile balance. The quasars brought us into brightness far greater, ancient black holes feeding on galaxies, releasing jets across unimaginable distances. In those beams, energy screamed outward, visible across billions of years, reminders of immense power locked within space-time. Their glow pierced silence, carrying signals from when the universe was still young, faint light still reaching our telescopes. The discoveries of exoplanets widened the story. Countless worlds circling stars more numerous than grains of earthly sand. Through observation, we traced atmospheres, temperatures, and possible oceans, building pictures of unseen landscapes. The evidence suggested endless strangeness, never confined to what Earth alone offers, but stretching toward infinite planetary varieties. So the universe itself became more alive, filled with countless paths of possibility. The flow of the narration carried us slowly, not rushing facts, but laying each detail beside gentle thought. At each pause, your breathing slowed naturally, following the rhythm of balance and softening awareness. The science was never separate from calm, but fused into meaning that guided body and mind. So the script itself became like twilight, half fact, half calm, and wholly restful. The truth of creation is both grand and small, woven into galaxies and whispered into single atoms. From fusion, stars create elements. From dust, planets form. From chance, life sparks into hidden corners. The patterns hold steady, repeated in every corner of space, carried through billions of years of cosmic history. So the awareness of it soothes us, not needing full knowledge, but simple recognition of steady order. The mind drifts when hearing such stories, thoughts quieting as detail merges with cosmic rhythm. Each pause lets the body loosen slightly, until words become background music of the universe. The calm comes not from silence, but from steady story, carried with patience across sentences filled with soft pauses. So the purpose becomes clear, to let both mind and body rest within cosmic continuity. The telescope of imagination extends beyond the night sky, into visions of worlds unseen but real within cosmic order. Through dreams, you travel among exoplanets, quasars, galaxies, each detail placed gently before your awareness. The narrative carries you forward, not demanding effort, but giving only presence, a slow rhythm of quiet understanding. So the flow becomes endless, like orbit, circling but never harsh, only gentle. The connection to these worlds is more intimate than distance suggests, for atoms within you were forged by ancient stars. Every breath you take carries hydrogen born minutes after the Big Bang, matter unchanged yet alive within your body. The unity is undeniable, reminding us we are not apart from the universe, but expressions of its ongoing rhythm. So the knowledge becomes comfort that we belong within this cosmic fabric. The endings of stars bring beginnings elsewhere, just as cycles within galaxies feed generations of life. Through death comes scattering, through scattering comes renewal, and through renewal, possibility finds new form. The circle of existence is eternal, moving across scales larger than thought, yet mirrored within living breath. So the awareness is calming, that nothing truly ends. It simply shifts into new stories. The story of the cosmos has no final chapter. It continues outward, in galaxies we may never see. In rest, we accept that not every answer is needed, and that mystery itself is a form of peace. The narration you hear drifts into your own thoughts, merging with memory, imagination, and quiet silence. So the journey ends not with conclusion, but with surrender to infinite continuation. You may now rest within this rhythm where galaxies expand without pause, and fire and ice worlds drift within endless orbits. The cosmos itself will carry on, patient beyond measure, eternal in pattern, while your body slows into calm. You are part of this, not apart, held within the same fabric, connected to every star by matter and breath. So tonight, as sleep takes you slowly, let the universe cradle you, in silence, in balance, in timeless continuity.